Hey everyone. In this video, I'm going to explain inheritance concept. So, what is inheritance? Inheritance is the mechanism of deriving new class from the old one. Here, old class is known as a superclass and new class is known as a subclass. Here, so the subclass is going to inherit all of the instant variables and the methods which is defined in a superclass. Okay. And it also adds its own unique elements in the subclass. So thus we can say that subclasses are such specialized versions of superclass. Okay. So the main idea behind this inheritance is, so inheriting the properties of a new existing class to the new class over here. That means it is having an important property called reusability. That means whatever the properties which are already existing in this superclass, so it will be, that means the subclass will be inheriting those properties from the superclass and it will be used in the subclass. Whatever the old class we are saying, so the old class is also called as a base class, superclass, or as a parent class. And the new class is called as a derived class, subclass, or a child class. Here in inheritance, the object is created for the subclass only. And so this is how we are writing the syntax of a inheritance. So this is the subclass. That means this is the new class and it wants to inherit the properties of a old class called superclass. For doing that one, we are having the keyword called extends. So this extends keyword will be inheriting the properties of a superclass to a subclass. Okay, this is how we are representing that inheritance. Class, subclass name should be followed by the extends keyword and then whatever the superclass we are having, that superclass. So in that again we can additionally add new methods and new fields in the subclass. That means, so this subclass will be inheriting the all the properties and methods of the superclass along with that one. So this subclass can create its own methods and fields in this subclass. Okay. Next, coming with the types of inheritance. We are having the various types of inheritance: single inheritance, multi-level, hierarchical, multiple, and then hybrid. Coming to this single inheritance. Here, the class A is the superclass, that is old class, and class B is the new class, that is a subclass. Okay. So now the subclass B is going to inherit the properties of the class A. That means how we can write class B extends class A. Okay, so we are calling this as a easy relationship. Okay, here, so the subclass B is going to inherit the properties of superclass A. Because class B extends class A over here. So this is nothing but a single inheritance. Here, one subclass is deriving from one superclass. So next, coming to the multi-level. So in multi-level inheritance, the class is derived from the derived class over here. So if you observe this diagram, here I have mentioned like the class superclass called A, and from that superclass, the class B subclass has been derived, and again from this subclass, another subclass has been derived called class C. That means how we can represent this multi-level. So class C extends class B and class B extends class A over here. Okay, here this is a super class. It will be, that means it will be giving the properties to the subclass, and again this will be sharing the properties to the another subclass called class C. So here the class is derived from the already derived classes. This is nothing but multi-level. Next one, hierarchical. So here we'll be having one base class but many derived classes. Okay, that means here the class A is the super class and class B and class C are the subclasses. So these two subclasses B and C can able to inherit the properties of a superclass simultaneously. Only one superclass and then more than one derived class. So can able to inherit the properties of a superclass called A. Next, coming with multiple. So coming with this multiple, if you observe the hierarchy, we'll be having only one superclass and then many derived classes, right? Only one superclass and more than one derived class. Whereas in the multiple, we'll be having more than one superclass and then for a single derived class. Okay, so that means the class C can able to inherit the properties of a two superclasses called class A and then class B. Okay, so that means this subclass will be inheriting the actually if you clearly say that multiple inheritance is not possible for this child. Okay, so here, but this multiple inheritance will be applicable for interfaces where we can represent interface 1 and interface 2, and these two interface properties will be implemented in this subclass. Okay, so this is not applicable with the extends keyword. It will be represented. So next, coming to the hybrid, we can see this is a combination of both the multiple and the hierarchy. So in the hierarchy, we are having only one superclass and then two sub. That means more than one derived classes. Okay, and again, if you come across with this one, here we'll be having more than one superclass and single derived class. So we can say this a hybrid inheritance is nothing but a combination of both the multiple and the uh, hierarchy in inheritance. Okay. So as we are having all these types of inheritance, we can say that we are having a more benefits of inheritance. That means increased reliability and reusability, and then we can able to share the code and consistency of interfaces, polymorphism, information mapping, and rapid prototyping. So like this, we are having so many types of benefits by using of this inheritance. So this is the example that is showing that. So this is my super class called calculation. Here I'm going to derive this, declare the two methods called addition and then subtraction. So in this addition, I'm passing the two parameters called x and y of type integer. I'm trying to add those two variables. Okay, and I'm trying to print the statement called the sum of the given numbers. Okay. Next, again, I'm having a method called subtraction with the same integer type of two variables called x and y. And here I'm going to represent x minus y. And here I'm trying to print the statement called the difference between the given numbers. So this is my superclass. Now I'm going to create a subclass called my calculation. And I want to inherit the properties of the superclass to my subclass called my calculation. So I'm just representing the extends keyword, okay, to inherit the properties of the superclass called calculation to this my calculation. Okay, so that's why I have represented my calculation extends calculation. And again, here I can create my own methods. No, so that's why I have represented the multiplication. Same with the parameters x and y with the type of integer. And here I'm trying to print the product of the given numbers. So now I'm writing the main method where I'm going to specify the variable values as a is equal to 20 and b is equal to 10. And here I'm going to create a new object called demo. Okay. Now I'm calling that object demo dot addition a comma b and demo dot subtraction for that variables and demo dot multiplication. If I try to run this program, okay, so here as my subclass is having, that means it is going to inherit the properties of all the superclass. Here it is possible to execute, that means addition, subtraction also along with this multiplication. Okay, why? Because so this subclass is inheriting all the properties of the superclass called calculation, where it is consisting of a methods called addition and subtraction. So that's why along with this multiplication method, we can also display the outputs of this addition and then subtraction method, which is existing in the superclass. So finally, the output will be like that sum of the given numbers and the difference between the given numbers and the product of the given numbers. Okay, so this is how we are inheriting the properties of the parent class to a child class. Next, using this super. Okay, so we are using super to call the superclass constructors here. Okay, so whenever a subclass needs to refer to its immediate superclass, okay, we can make use of the keyword called super. Okay, so this super has generally two forms. So one is with the super with the argument list. So that will be calling the superclass constructor. And next one is super dot member. So this is nothing but to access a member of a superclass that has been hidden by a member of a subclass. Then we can use that member maybe a variable or a method. Okay, then we can just represent the super dot member. Okay, then we can make use of that member of a superclass. Okay, so what is the main use of this super in this sense? Overridden methods that is allows Java to support runtime polymorphism, right? So by making use of this super keyword, we can just be able to make use of that variables or methods or else constructors. Okay, so here if you see in this example, so I have just defined a class box weight extends box. Okay, that means this is a superclass and this is a subclass. Okay, I have just represented double weight and here I'm going to represent box weight some parameters. Okay, I have passed with some parameters. Now again, I'm just trying to represent super W comma H comma D. See, these are the parameters that has been already passed in the superclass. Okay, so here mainly for this overriding concept, we can make use of this super. Okay, see for that one, so I'll just explain that super by making use of this example. So that is accessing the superclass members. Okay, so this is how I'm going to create a class superclass called A. Okay, and here I have just specified a variable called I. Okay, and again this class B is going to extend A. That means this class B is nothing but a subclass which is going to extend the superclass called A. And again here I'm just specifying a variable called I. And here I'm going to declare a method called B with the parameters A and B, and just I'm rewriting that. That means I'm denoting this I value with the B. Okay. Next, whatever the variable that has been declared in the superclass, that is I know. Here also I'm just representing it like I know. So before this I, if I represent the super in the sense, then this will be related to that variable which is existing in the superclass. Okay, that's why I'm just representing super dot I, which is equals to A. If I represent like this, it will be related to the I which is existing in the superclass. So if I'm going to represent like this, in the sense, this I will be related to the subclass over here. So if I try to print this one, okay, so and here I'm going to create a method called show. In that method, I'm just trying to represent display statements called I in superclass and I in subclass. If I try to run this one, for this one, I just want to pass the values called for the B. Here I'm just passing the parameters. No, for int A, that means for the A value, I'm passing the value called 1. And for the B value, I'm passing the 2. Okay, so if I try to run this program, okay, here the I in the super class will be represented like super.I. Okay, so where it is going to print one value. Why? Because here super dot I is equal to A, where this I is belonging to the superclass called A. So whereas this one I in subclass is plus I, that is I is equal to B in the subclass and the B value is 2. So this is how it is going to print this I in superclass is 1 and I in subclass is 2 for accessing the superclass members. Okay. So the main intention of this superclass usage is of overriding. So here we want to know what is this method overriding is meant. Okay. So in method override, so if a subclass has the same method as declared in the parent class, then we can say it is as a method override. Okay, with the same method. Okay, if you are trying to represent the same method in both the parent class and the child class in the sense, then we are calling the concept as method override. So what is the main usage of this method overriding in the sense? It is going to provide specific implementation of a method that is already provided by its superclass. Okay, so we are calling this method overriding is used for runtime polymorphism. That is with the same name. Okay, so we will be having more implementations. Okay, so the main rules for writing this method overriding is the method must have the same name as it's in the parent class, and method must have same parameter in the parent class, and it should be a easy relationship. That means it should be an inheritance. So this is the example which will be differentiating without method overriding and with method overriding. Okay, if it is a non-overriding, here see here, this is a class called vehicle where I'm going to represent a method called run. Okay, so in this run, I'm going to display a statement called vehicle is running. Okay, and now this is my subclass called bike where it will be extending the that means it will be inheriting the properties of a superclass called vehicle, and here I have just mentioned the normal main method signature, and I am not having any method which is same as the parent over here. Okay, so if I try to run this program, okay, so here it will be representing the statement like vehicle is running. Why? Because the subclass is not having the method which is similar to the superclass. Okay, so that's why if I run this program, it will be displaying like vehicle is running. See, if you observe this overriding, see, we are having a superclass called vehicle where it will be defining a method called run, and the statement it wants to print is vehicle is run. If you observe this method, that means this subclass, the class bike2 is going to inherit the properties of a superclass called vehicle, and again it is going to declare a method called run. In this run, again, it just want to print the statement called bike is running safely. Okay, and now it is creating an object for this subclass only. Okay, and if we try to run this program, here already we are having a run method which is overridden by this statement. Why? Because already we have a run method, and here we are trying to print a statement called vehicle is running. But again, we are trying to create a method with the same name which is existing in the superclass. And here I want to display the statement called bike is running safely rather than this vehicle is running. So for that, what I'm trying to do here, I'm creating an object for the method which I have created in the subclass. So here this void run is overriding this previous existing method in the vehicle, and it is going to display the statement called bike is running safely. Okay, so this is how we are differentiating the non-overriding with the method overriding. Okay, so in this video, we have come across with what is an inheritance and what are the benefits of inheritance and what are the types of inheritance, example, and then superclass, and then method overload. Sorry, method overriding. Okay, thank you.